Is the saturation too much? Like I previously streamed on YouTube, and that's why this is named number two. Uh, there was a stream before this. It was on YouTube. Just did a test stream. The original stream, like the first one that I did, it was in Twitch, and I was just trying out different platforms. So yeah, that's it worked out, and funnily enough, in both cases, in both my streams on YouTube and Twitch, the power went out maybe like after 20 minutes or 30 minutes or something like that. So you know, it's in the and we don't actually have backup here, so what can you do? Yeah. So let me just I think the quality is good. The stream quality I'm currently, yeah, it's really good. Yeah. Okay. Then let's get into it. So I think I will be streaming on Twitch because it's generally better for streaming and streamline, and then I will maybe upload the VOD to YouTube. So yes, that should work. Yeah. And I think everything's all right. Okay, so we were, yeah, cache symbol, and I had to click the cache symbol here. So basically, we had like I don't know why I'm saying we. I was having some problems parsing and generic types, basically. Also generic types, and we were caching. Like I was caching symbols, and then using them later for expressions and for like type names and things like that, variables and things like that. Initially, this function right here that you see, parse symbol, it parses a symbol. Symbol generally means some sort of identifier or a mix of identifiers and some other tokens, things like that. It represents an entity or a symbol in the not in the language, but defined by the user. So yeah, that's just what parse symbol means. So whenever you encounter an identifier, it's whenever the identifier is encountered within the language, you call this, and then this actually parses the symbol, like the entire symbol. It might not just be just one identifier. There might be like other identifiers chained within it, and it caches that particular symbol, or it is at least supposed to cache. Previously, this returned a pair of string and the index at which it stopped parsing, and I have changed it, like in my previous stream, to return a cache symbol, which is like a dedicated data type that represents a symbol. And like in the first stream, we actually changed the cache symbol to include the token index because we need that for expressions and things like that. And so that's that. Let's see. Okay, the stream quality is excellent. Great. And cache symbol. Okay. Oh, wait a minute. Yeah, name, token index, and file placement. So name, obviously we have name here. So name, token index. Actually, when this function starts, we have been passed the starting position where we will start looking for tokens. So we can just pass start and then tokens at start and file placement. I think this is the proper way. Oh yes, it is indeed. And here, okay, here there is no, this technically should never happen, right? Because we will not be calling cache symbol if we don't encounter an identifier. So technically we should be throwing an error here rather than returning an empty symbol, because we wouldn't because an empty string won't be lexically analyzed as a token, so it won't be passed to the parser. So there won't be an empty, you know, and we won't be calling this particular parsable function if we didn't encounter an identifier to begin with. So we can just throw an error instead of returning here. Throw error. This is sort of like an exit function, and like not both parser, letser, and the IR generator, and also the CLI all have their own versions of throw error. And I will be changing this implementation later, at a later point, and most probably, indexing the errors, possible errors that the compiler will throw, and redirect the users to a particular URL or something like that, which I believe is the better way of doing it. So that's that. Let me see. Yeah. And through error file placement tokens at start file placement. This error technically should never happen, but we'll just leave it as such, and maybe error 2 to change this after verifying that the situation is never is never encountered. Okay, so identifier found for parsing the symbol. I don't think this particular message matters that much. So that's that. I think we just took care of that. And previously this was different, like the return type, it was different. It was string. The first member in the pair was a string. So I have to change the places where I used. Yeah. First dot name. Wait. Okay, we are passing a symbol. We're using for variable expression. Okay, it is indeed an expression. But are you that sure that it will always be an identifier? Oh, sorry, it will always be a variable. Let me see. Rawful to do check if this is indeed the only scenario possible scenario. I think for example variable expression, what of yeah, because anything else won't actually start with identifier being the case. So for example, if you're declaring a namespace, which in the language is called a box, so if you're declaring a box and you're providing a name, right? So you wouldn't actually start with the name, like not you, the user. No, the parser won't start parsing at the name. It will start at the keyword box. I can show you within the source code of the language. Box. This is actually keyword. So I'm sorry that it's not as highlighted as other keywords, because this was a recent change and I haven't changed the VS Code extension to reflect that. So yeah, the box is where the parser starts, and box is a recognized keyword. So whenever the parser sees this particular thing, it automatically expects the other thing to be an identifier. So we never start with the new space word. We start with the box keyword. So I think this should work. Yeah. And yeah, this is all right. Okay, so technically I have only used that. Season. We will change this as auto sim sim res equals parse symbol of I, right? Yeah, and if no, it will always have a value. It is supposed to have a value. That's the point. So then we will assign it to the cache symbol itself. So here we will say sim res dot first, and the parse symbol. Yeah, it's inclusive. The value that we pass here is inclusive. So if we pass I, the parse symbol function, it starts at I, and it also checks the token at the I position. But some other functions, they don't do that. I think expression is like that. Yeah, the mostly the ones that have the arguments named as from and to, those are exclusive. The positions are exclusive. So it's almost as if that checking or parsing is within a container, you know. So yeah, okay, I'm currently looking at the stream manager and everything seems to be all right. Okay, so that's that one viewer. I think that's just me. Yeah, okay, parsing. Okay, so we have simple. I don't think we have to do anything else here because we have cached the simple. So it's some symbol. We don't know if it's a variable, if it's the name of a type or anything like that. So if we, and in the case of type, it could be a generic type. Generic types are like not supported in the backend of the language as of right now. I mean, the IR generator, we are using LLVM, and the IR generator doesn't actually, like at this point, doesn't actually haven't written code to support the AST, and all those things don't have support for generic types. And it's a bit of a challenge because, it's not an easy thing to do. And like generating code is not the hard part. Representing it and successfully regenerating code on different variants of that generic type, that's the bit of a challenging thing to do. So yeah, so and when it comes to types, when you're parsing, we have the same syntax as Dart and C++ for generic types. That is, let me see, yeah, this one right here. So it's basically the type parameters are enclosed within a less than and a greater than symbol, and this we'll have to have a special case to check. So that's that. Let me see. So here we are passing time. We don't have to. Why? Because why would we? Why would we? Right? Cache symbol. So the symbol would be cached. We either yeah. So the symbol will be cached. We either have the name, the value, which we can use in some cases. For example, the one I showed you before. Control find parse symbol. This is present in two cases, right? So here we are just using the name. We don't need anything else. But in other cases, we want something else, right? Sometimes we need the token, like the starting index at which the token was parsed, because we will have to reparse it if we are encountering an expression. At an expression, like parsing an expression, you can't do that in the middle, in the language. At least the way parser is, our parser is made. You can't start from the middle. You have to start from the start. And I mean middle in the sense that you have a variable name, but it's not just one identifier or one like word. Maybe it's contained within different namespaces. So there are symbols between the different names. So you have to parse the entire thing, right? And once you parse the entire thing, you can't just start an expression when you encounter an operator. No, you have to start from that the symbol that you already parsed. At least that's how I can actually easily change. I can actually easily change the parse expression function to receive a value, something like cache symbol, and then continue parsing. But I'm not sure if that's a great way to go about it. And technically that is a great way because let me show you. So for in this particular example, new space is a box or a namespace. My space is also a box or a namespace. Hello is a variable, by the way. And this symbol right here, the single quote, it is used as a way to access the members of an object. So this is actually an expression, right? The entire thing is a statement, no arguments there. But this statement or sentence, as it's called in this language, actually has one expression inside. So when you parse it, like the first three things, not three, technically 5 things. So new space colon, my space colon, hello. These are all done by the parse symbol function, and it returns a pair of cache symbol and the last position of the token. Yeah, and it's cached. We know that when you encounter this symbol, we know that it's going to be an expression. So what do we do? Like the one, like technically the one I want would be, I will be passing the cache symbol to parse expression, and then it can just take that value and then carry on the parsing, which I think is the sane way to do it. Or the one that I was talking about right now would be, we already have this cached, right? The symbol cached, and it also has the token position, the starting token position. So we just parse it again inside the parse expression function. I don't know. Maybe it should work. We can always, inside the parse expression function, let me show here. Parse expression, what is it? Wait, is it? Parse type. Oh, yeah, parse expression. We can add another argument like const LLVM option of cache symbol. So symbol. So if we do this, the first one is optional. So technically this should be compatible with all the other functions, all the other function calls that we have made, right? Yeah, it should. I think this is the same way to do it. Let's just do that instead of parsing it again. That's, I mean it's mostly maybe like 4 or 5 tokens, but why do additional work, unnecessary additional work? Yeah. Symbol. Yeah, wait, let's just go back to the header. Control find yeah, const LLVM optional of cat parser cache symbol. Yeah, symbol. We have to handle this too. If symbol is, we already have a cache symbol. Yikes. So yeah, it makes total sense to use, to pass a cache to symbol and then continue parsing. Why didn't I try? Yeah, symbol. So this should work, right? It is being moved here. Yeah, the default constructor should. Not default constructor, but yeah. This confused me. I don't like, not confused, I don't like this index. I don't know why. It makes sense, I guess, because you don't have to do this, which is alright, I guess, but I don't really mind doing this. And this makes this at least reads in a more sensible way. Okay, so this means let me see, where is the child token? There is no child token. Wait, oh yeah, I haven't completed that, I think, or maybe I did. Yeah, I haven't completed that part. So yeah, this should work. This should totally work. I haven't completed a parse expression. Let's just then mark that it is not complete. Where is parse expression? Oh, center find. Yeah. And we have to, what do we have to do? Is token type, parenthesis open, parenthesis close, all that. Hashtag just means pointer. Binary operator, we have to do unary operator. The most embarrassing thing in a low level language job, related job, is forgetting the break sentence inside a switch case. And it's actually a stupid thing, because it's stupid that you have to manually mention break inside a switch statement. Dong Kong Kong. Sorry about that. Oh, you're Malu. Sorry about that. എനിക്ക് സുഖമാണ്, ഇപ്പോൾ ഉണ്ടോ എന്ന് എനിക്ക് ഉറപ്പില്ല, ഇതിൽ ടൈം കാണിക്കുന്നില്ല. ഞാൻ എൻ്റെ ബ്രൗസറിലാണ് ഇത് സ്ട്രീം മാനേജർ വെച്ചിരിക്കുന്നത്. So for those who don't know, the person just send me a message in the native language, in my native language, Malayalam. So yeah, can I mention? Yeah, I'm new to Twitch, so sorry about that. He's asking me to turn on notification on chat, and I like, okay, yeah. Like I have to buy another monitor. The current one is not even HD, full HD, not even full HD. Sorry, it's HD but not full HD. And like I use Blender, DaVinci Resolve, and it's not enough. I have a graphics card, like a high-end graphics card, which I bought recently, but the monitor itself is absolute awful. So I have to buy, which I will, but yeah. Technically, yeah. Missing, yeah, break. And so I actually, in my job, I actually forgot once to do the break thing. So like every time it fell to the default case, and you actually don't need break in the default. I don't know what I'm doing. Yeah. So it always fell into the default case, and it was really embarrassing. But this is actually design flaw in C and almost all languages that follow the C style syntax. You shouldn't have to provide manually the break clause. Instead, like, I know why it's there. It's because if you ignore it, or if you don't avoid it, it falls to the next case. All right, a lot of people want that. But here's the thing. Let me just show you. Why is it not this? So here, case 1, and you do something here. Case 2 value. Okay. Case 2. Why it should be implicit, and if people want it to be continued, they can do this. Why isn't the syntax this? Or maybe instead of 2, we can just say and, or something like that, some keyword here, and after that you write the case. So here the breaking behavior is implicit unless they provide this particular keyword. They do this particular keyword before the case keyword. So in this case, you continue, like from after case 1, you continue to case 2. Instead, like in all, technically all low-level languages, almost all, not all, but yeah, you have to do this to break. And if you forget it, for example, if I remove this particular thing, then it also executes the case 2. This shouldn't be the norm. I know, it was a bad design decision, and then they just continued with it after C. C++ continued with it, and technically almost all languages after that followed C style syntax, they just continued with it. So it's kind of sad, but it's really embarrassing when that happens. And it's not just embarrassing. If you accidentally forget to use this particular keyword here, it can also be tragic. I mean, it can actually lead to problems, or it's almost the same as null. The creator, or the one who created the null reference type, he apologized to the programming world that he did that because it led to billions of losses. So it's almost the same as that. And I mean, I can understand that C had this, and also C++, because C++ was also done in 1989, 1988. I'm not sure about the exact date, but why do modern languages have the same thing? I guess they just want, the people to continue with what they already know. But then why just create a new language in the first place? You are trying to solve issues that other languages have. Otherwise, there is no point in creating a new language. I know, not all languages are like that. Some languages are created, for fun, as a part-time thing, and as a joke. Like, for example, esoteric languages like Brain F. I'm not going to swear, so yeah. But yeah, what can you do, right? Yeah. Case token type child. By the way, this token is basically the single code that you saw in the source code, the cat code. This particular token, it's named child because it's accessing a child member. Okay, so I have to do. I only recently picked up in the Anger thing. Like I have been writing comments for to-dos for quite a long time, but I recently installed this extension and it's pretty great. I think. Yeah, you can also do fix me. There are so many things. See, section, anchor, fix me, link, note, review. Pretty great. Oh, link. I didn't actually saw that before. stub, to do, great. To do, and handle cases. Okay. To do, throw, error, question mark, and so that's that. So what were we? We were ranting about. I was ranting about break statements and switch cases. So yeah. Okay, parse expression. I just have to pause LLVM dot none, not dot, but yeah. So if there is no value for the symbol, that gets initialized to that thing over there, and then that then it's as if the expression it just started. So yeah, that should work, totally work. And I'm glad that my brain works in the way it does, because like most of the time I don't actually have to rewrite a lot of things. Some things that I have done without knowing previously conveniently becomes it becomes convenient when I want to change something. So thank God for that. Yeah. I don't know if you're still the Hong Kong. കേരളത്തിൽ നിന്ന് എവിടെയാണെന്ന് അങ്ങനെ പറയുന്നത് ചിലപ്പോൾ ഡോക്സിംഗ് എന്ന് പറയുന്നത്, അപ്പോൾ ചോദിക്കുന്നത് ശരിയാണെന്ന് അറിയില്ല. ഞാൻ പാലക്കാട്ടിൽ നിന്നാണ്. ഓക്കെ, ഇപ്പം ഉണ്ടോയെന്ന് അറിയില്ല. ഒരു വിയർ കാണിക്കുന്നുണ്ട്, എനിക്കറിയില്ല. The Twitch is showing me one viewer in the stream manager, but I'm not sure if that's just me, because it's also showing my stream to myself. So I don't know if that's just me. So yeah. LLVM none. System. To wait. Okay, this should be different. Okay, then we will have to check if I made a mistake here. Separated expressions. This is technically wrong, or this is flawed, because I will explain it. Fixed. Yeah. Find first degree separators and then parse. Here's the thing. Initially there were no type parameters. So if you have like some code enclosed within parentheses, and if it's if it's supposed to be an expression, if there are separators, commas inside that enclosed within the parenthesis, then you can like consider the comma as a proper separator, that this is one expression and this is another expression, and the comma is in between that. But if there are type parameters, then or generic types, then the comma could come between that, right? But the problem is, generic types, to specify generic types, you need the less than and the greater than symbol, but those are also used within expressions. So that's the problem. We are parsing an expression, we don't know if the less than or greater than is supposed to be an expression or just part of the type parameter, or generic type. So that's that. Okay. Yeah. Okay. I think. Yeah. I'm seeing live. Okay. Yeah, parse and this is where we parse. Yeah, fix me. Yeah, we'll have to fix this. Definitely to fix this. Push back. Child. Parse sentences. This also have to be fixed, or at least checked. But I think for sanity, it's better to leave it as fix me. First primary position. Let me see. What are we finding? Okay, we won't be having any problems here because it's stop. It's not the separator token, but parse expression itself. Parse expression. Let me see. End has value. Just start. Yeah, this is flawed because we changed the caching system for symbols, so this code is actually flawed. So if this is the case, then we need the CSM variable to have a value, so we have to check here. So it's not just end has value. After that we have to check. Wait. Okay, we are parsing a sentence, that's why we are looking for an end of the statement, so that makes sense. But if it's child, yeah, so the other check should be before even this. So if CSM has value, else through error token.file position. Oh wait, is it token.file position? Yes, because we can't use CSM, so what's the point, right? Here it's more sensible to use CSM or cache the symbol dot file placement. Dot get value dot file placement. Fix me. I think I just fixed the code, so let's just leave it at that. CSM. Yeah. Get value. Yeah. Cannot find the end of the sentence. Here, no expression or value or entity found to use the to access the child of. Yeah, I think that's a better way to put it. So that's that. Okay, I'm like occasionally checking the chat to see if there are any. I don't want to be rude, so yeah, I'm not expecting a lot of reactions or chat or anything, because it's kind of like technically my first stream. Not technically, logically. Technically it's my second stream on Twitch. So yeah, I will be uploading this to YouTube at some point, but unedited. I won't be editing it. It's quite long. I don't want to, and I have other things to do. I have a full-time job, so parse expression. Okay, this is kind of like a sensible place to not pass any value to parse expression. This is a very great example of it. So here we are bumping into an identifier, and this is a sentence. We are passing a statement, or in the language it is called a sentence. So when you do this, wait. Okay, yeah, never mind. So when we are like bumping into an identifier, there is another check for another case, but in this case, what this is that we are checking if it is a declaration, and not just that, we are checking if this is a inferred type declaration. So to give you an example, if I am typing let hello equals human, here the type of the variable hello, it's not actually variable, it's a constant. By default everything is constant, so the constant hello, it will have the type human, and it is inferred because you're using the let keyword. You don't actually have to use the let keyword if you are doing this. See, also where is a way to say that it's a variable, and if you want that to be inferred, that declaration also to be inferred, you just say let var hello equals human. So this is the case that we are handling right now. Wait, what? Okay, I just minimized the wrong window. Yeah. So we are checking if either the previous token is a let keyword, or if the previous is var and the one before that is let. So yeah, so this is an inferred type inference, example of type inference based declaration. And here we just want the entire expression, because anything after the equal sign is an expression, right? So we just want the entire thing. Also, I'm seeing a potential problem here, or maybe it's not. This is calling the constructor. Yeah, I didn't actually think about this. This is actually calling the constructor, but here's the thing. How do we know if it's the constructor or if it's a function? I mean, all languages do this, and obviously you check it after parsing, not before it. But then I will have to the part in the AST that handles function call, that will have to be really generic. But I guess it's all right. Yeah, it's going to be all right. I mean, if you have enough time, you can solve anything. And also resources. So, in this case, it's basically time. Let me see. Yeah, so that's handled. Then expression sentence. Okay, this is another thing. Wait. So CSM has a value, meaning okay. Yeah, makes sense. This should no more be here, right? You're parsing the symbol, we are storing the symbol, and then we just break the flow, let it move on, and then we check if Yeah. And in the next iteration, we check if we bump into an identifier, we check, if CSIM has value. So that makes total sense. Yeah. Also, okay. Yeah. Let me see. Yeah. I don't think I will be streaming for long. I'm obviously not used to this. And I don't want it to be too long. So yeah. Here we have assignment. We just plainly assume that it's an expression, and so this. However, here, do we know if it has a value? Oh, we do. Then we'll have to pass it. Okay, to do. There is another error called with the same error worded an actual word. I'm not sure. Same with the same error in explained differently. Make sure that these remain the same. So my plan for the error system is that instead of calling throw error, like after I redo the error system, we will be calling a function for each different error. That way it's much more, trackable. I don't know if that's the proper way to put it. It makes much more sense, or there is a better representation for the error. Parser expression sees them because it has a value here. This also to do sync errors. I think that's a better way to put it. Maybe for this I will leave it like that, but this sync errors. Yeah. Invalid expression for variable. I think that also has it, but we'll leave it like that. Oh, sorry about that. Yeah. It was file placement, push. Yeah, so we just passed an expression, and the expression starts with the CSIM. So we'll have to merge those two. CSIM dot get value dot file placement, and then we do exp dot file placement. Wait. Oh, wait. End. Okay, end. File placement. We already know the end. Wait. Okay, it's a sentence, so that makes sense. If it's a sentence, it makes sense that it is an expression, and we want it should have an end. The period. So it makes sense. Yeah. Get value. File person. Wait. What are we getting? Oh, it's so. Yeah. Tokens at file placement. Yeah. Okay. By the way, file placement, this constructor, it merges two placements. File placement is basically it contains the URL of the file and the starting position and the ending position of the particular token. So there is a normal constructor where you just provide the URL of file, the starting position and the ending position. There is another constructor which merges two placements. So it takes the starting of the first placement and the ending of the second placement. If the file URL is different, it just copies the first placement we provided. If it's the same, then it merges two placements. So it doesn't merge technically. It increases the range to span the range specified by these two placements. That sentence seems to be confusing, I think. So yeah, that's that. Okay, I can see my stream. Yeah, it's going well, no problems, no lag. Yeah. For some reason, streaming on YouTube requires you to have a very high bitrate, and the problem is the colors are very desaturated. Seriously, I mean, not my face. I don't really mind if my face is desaturated, but the code itself, VS Code, looks really desaturated, and you also need like very high. Not need. YouTube recommends like you can have up to 51,000 kbps, which is pretty high. I mean, at least for my situation right here, India. So we even and I provided something like 7,000 kbps. Even with that, the colors are desaturated and the quality is not that great. Twitch, the maximum I'm allowed to is 6,000 kbps, but even then, it looks really good. So I don't know what's happening there. I think YouTube has some, like, I guess it's all right for. Okay, I just dragged something. Yeah, I guess it's all right for YouTube to have a streaming platform, but it's not polished, I think. So yeah. Yeah. I think I'm currently looking at the Twitch stream, and the colors are almost equal to. Yeah, I think Twitch also does the same thing. Maybe the colors are a bit desaturated. So I have increased the saturation a bit in OBS, so it should work. For YouTube, I had to like crank it high. For Twitch, I don't think it's going to be an issue. Yeah. So let's get back to it. I think I might be stopping the stream pretty soon. But yeah. So that's all taken care of. What else is there? We handled that. Identifier, where. Yeah, this. Oh my god, I shouldn't, because it's kind of like a small statement. I might just fix. Okay. So there already is a value in season, which means, what does it mean? Which means that this is a type declaration, isn't it? I will show you in the code. So imagine the declaration is like this: hello equals hello, or you're calling function called get hello, something like that. Yeah. So you're doing this, and so this will be passed as a symbol. It will be cached. Then you bump into an identifier. When you bump into the second identifier, you already have a cache symbol that is not null or none. So you can just assume that it's going to be a type, right? Yeah. You can ask, what about this? What if there is a type parameter? What if there is a type parameter, right? Something like this. So in this case, this particular first word will be cached, and then you don't bump into the identifier token. No, you bump into the less than token, and then you check if this is a type or something else. So I don't think this is going to be an issue. And you complete until you reach here. Then then the case would be you have a type. You already have a type here, and you are bumping it to an identifier. That has to be covered here. I don't think we are covering that scenario. I think I previously did. I think I removed it. I think. Yeah. Oh yeah, we are definitely handling it. Yeah. Because see, we are using the cache type. Technically this, yeah, we don't have to find it. We are using the cache type, so this is already handled. Because we are looking if cache type is empty. If it's empty, this will be the case. If it's not empty, we will come to this. That makes sense. Let me see. Yeah. So CSIM has value and we are bumping into an identifier. It means it's a declaration. And if CSIM has value, we have bumped into an identifier, then the types also cannot be non-empty. I mean, it has to be empty. If it's not empty, that means there is some sort of error, or we forgot. I mean, at least I forgot to clear the cache, which I won't be, because I have included the code to do that. So yeah, that's that. And yeah, this should work. Fix me handle this case. So CSIM has a value, which means we can just plainly assume that it's going to be what yeah. If okay, wherever we are using this value, we also have to clear this value. Okay, one problem, not a problem, one technicality that you have to keep track of is that when you're using optional types, in at least in the case of a parser, to recursively check for values and store them and cache them, you have to reset the value whenever you are done with it. So yeah, you have to manually do it. There are not going to be any warnings or anything like that. Why isn't this auto? Initially, all of the variables in the source code were typed, strongly typed, obsessively, unnecessarily typed, and then I changed it to auto. Achievement unlocked or something. Yeah, I don't care. So auto, because in many cases I'm calling the constructor, and having the type right here doesn't make a lot of sense. And even like in this case there is no constructor here, and technically I'm unsure of the type, but I'm really aware of familiar with my code base and aware of what's happening, so it doesn't matter. This way it's not a lot of visual noise. Technically we don't even have to do this. You can just place it here, and this should work. Yeah, this should work. Definitely work. Yeah, see, wait. Oh, I keep this won't work. I remember why I did that. If we are popping the vector, oh my god, that's really embarrassing. We are popping the vector, so before popping it we need to store the necessary value or the important value, and then we are popping it, so that value is no more stored in the vector, so we can't actually use it here. that makes sense. Let me check the stream. Yeah, it's all right. No problems. I think that might just be like I have just crossed 1 hour mark. I mean, I am not intending to stream for hours. So, I might just stop here or maybe just finish this off. Oh, yeah. See, this is the problem to do. Handle this. Yeah. Okay, handle this. And so we have the type, we have the identifier or the name of the variable, and then if is next. Token type assignment or is next token type from I, then that means it's going to be an expression. It's going to be an assignment. What am I going to do? By the way, from is kind of like a special thing. I mean, it's technically not special. It's, I guess you can call it syntax, sure. So imagine you have specified a type here, hello. You can do this. That's basically it. But it's sort of like, it's a way for you to mark the visual flow of data and conversions, to mark conversions within the language. So, you can do this, hello, I don't know what's the type here. So maybe you can do this, get something else. So, something else have some other type, and we are converting that to hello and assigning to our variable. So you can also do this hello to some other type. This will also work. So this from syntax is to be consistent with that. And if your data type is compatible or convertible to words and compatible with an integer, you can do this from 1 to 3, as simple as that. At least that's how I want it to be. From yeah. This next assignment from this means key assignment, and if it's from, then we can just expect that the thing after that to be an expression function called constructor. I hope it's not a constructor, because then if it's from, then what's the point of using a constructor, explicitly calling a constructor. We will look into that. Potentially handle from separately. What is the separately? Yeah. From. I guess from should be. Okay, I think that's about it. I'm going to end the stream. Maybe a different time. All right then. Thanks for watching. If you're watching in the future, check out other stuff. Thank you, and I think that's just it. I will be uploading this to YouTube, so yeah. Okay, yeah, obvious.